let's go over jump discontinuity. So jump discontinuity, and this will be the first example of it. So it'll be example 1. Say we have the graph, or the function, f of x equals, I'm going to send a few different colors. We'll say x squared whenever x is less than or equal to 1. And it'll be x plus 2 whenever x is greater than 1. Now, we could do all this algebraically, but I think it's a little bit more instructive to graph it at the beginning at least. So we'll graph this. So anytime x is less than or equal to 1, put 1 right here and 1 right here. It's going to follow the y equals x squared graph, which I think most of you are familiar with. Looks like this. Until we get to that point, and then we stop. Then, whenever we get to x being greater than 1, we plug into this function. So we put 1 into here, and we get 1 plus 2. So right at x being greater than 1, we get y equals 3. So we'll put that up here. And then it looks like we're just going to go up at a even pace on the x and y side. So it'll be like this point right here would be x equals 2, y equals 4, then x equals 3, y equals 5, and so on. That's unimportant. So this is called a jump discontinuity because there's a big gap in between where it stops from one place and where it starts from another. Let's look at the limit. As x approaches 1 from the left of x squared. Well, that clearly, as x is getting closer to 1 from the left, y is getting closer and closer to 1. Now let's look at the limit as x approaches 1 from the right of x plus 2. Well, as we get closer and closer to 1 from the right, y gets closer and closer to 3. So that'll equal 3. And because here, whenever we actually plug in 1, we get the value 1, we can say that this whole function is continuous on the left and it's discontinuous on the right. So the limits of these two things are not equal.